An outbreak of the measles in Washington state, not stopping many in that state from protesting vaccinations, and the outrage is making national headlines.
Actress Jessica Biel wants everyone to know she is not an anti-vaxxer.
Hundreds rallied to preserve their right not to vaccinate their children.
Do you consent? No! Are you informed?
You've probably seen more and more stories like these recently. But while vaccine hesitancy might seem like a new thing, anti-vaxxer sentiment has actually been around for over 200 years, since before people knew that bacteria and viruses cause disease. What stayed the same is confusion about how vaccines work and a deep mistrust of public health institutions. So in this series, let's take a look back at the history of vaccines to understand what they are, how they're made, how they're tested, and how they've changed through time. The Smithsonian's National Museum of American History is home to a huge medical history collection. When I visited recently, I met with Alexandra Lord, the chair and curator of the Division of Medicine and Science, to talk about the disease that changed healthcare forever. Would you start off by just telling me what smallpox is?
So smallpox is a highly infectious disease, and it was widespread basically in Africa, Europe, and Asia, beginning about 6000 BC. Smallpox has a high fatality rate, and smallpox also leaves scarring among those who survive, intensive scarring.
Smallpox was highly contagious, and there was no cure. But in Africa and Asia, there was a traditional technique called variolation that can make a person immune to smallpox for life.
They would often make a small incision in the skin, perhaps dip a thread in a smallpox pustule, and then insert the thread into that cut. In Asia, they tended to use dried scabs and blow them up the nose into the respiratory tract.
This sounds pretty disgusting, but it worked. To understand why, you have to know something about how our immune systems fight disease. The first time you encounter a particular germ, your body needs to develop the right weapons to fight the intruder. Bacteria and viruses release and are coded in antigens, basically foreign molecules that help the germs do stuff like invade your cells. So your body uses proteins, called antibodies, to bind the antigens and flag them for destruction. Only one antibody can bind to a particular spot on a single antigen, just like a lock and key. But when you first meet a particular disease, it can take a while to find the right antibody. And in the meantime, the germ can make you really sick or even kill you. However, if you manage to pinpoint the correct antibody and kill off the invader, your immune system will remember which antibody it used. So if you ever meet that germ again, you can quickly spring into action and neutralize the germ before it makes you sick. Variolation gave people a very mild case of smallpox. Doing so allowed the immune system to build up the right antibody arsenal. So if they ever encountered smallpox again, they'd be protected. By the 1700s, variolation started spreading around the world.
Smallpox variolation was actually brought to the United States by an African slave, Onesimus, who belonged to Cotton Mather, who is a famous Puritan minister. By the time that the American Revolution breaks out, George Washington, who had actually had a case of smallpox and then recovered, mandated that soldiers who had not been exposed to smallpox and had the disease be variolated. He was afraid that the British might use smallpox as a biological weapon against his troops.
But inoculating people with live smallpox could be dangerous. About 1% to 2% of patients died after being variolated.
Today, we would say 1% to 2%. That is way too high a fatality rate. But in the 18th century, when that's the only way to protect yourself against smallpox, that was considered an acceptable percentage.
Eventually, something safer came along. There was some conventional wisdom that dairymaids never got smallpox. And a British doctor named Edward Jenner decided to look into why. He found that some dairymaids he met were infected with cowpox, which caused pustules on their hands. Cowpox is very similar to smallpox, but far less dangerous. So in 1796, Jenner performed a test.
He scraped pustules from a dairymaid and then injected it into an 8-year-old boy. Again, we would regard this as highly unethical today. And when he exposed the boy, his name was James Phipps, to smallpox. He discovered that the boy was immune to smallpox.
Remember, this was before germ theory, the idea that bacteria and viruses are what make us sick. And even Jenner didn't totally get why his test worked. But today, we know that Jenner was getting Phipps's immune system to develop antibodies for smallpox without actually exposing him to the disease. So when Phipps did encounter smallpox, his body knew exactly how to fight it. That's what vaccines are. They're a way to educate your body about a disease without getting sick, letting your immune system's natural processes do the work. Jenner called his new treatment vaccination. Vacca is Latin for cow. Vaccination came to the US in 1800, and right from the start, there was skepticism.
People found it worrisome, this idea of injecting yourself with a disease, and there was a fair amount of pushback. And the 19th century really sees the emergence of anti-vaccination movements, both in Britain and the US.
Initially, people were concerned about putting an animal disease into a human body. In fact, one British satirist drew a cartoon of vaccination patients turning into cows. Later in the 19th century, some people thought that vaccination went against God's will because God had given us diseases for a reason. And when states started mandating vaccines, tracts were published on how compulsory vaccinations violated civil liberties. All that said, for the most part, people trusted the smallpox vaccine. And throughout the 1800s, the number of vaccinations grew.
And the reason I think for that great faith is because people saw evidence of what smallpox did. Although vaccination became increasingly common, and in 1855, Massachusetts becomes the first state to mandate vaccination, people always saw evidence of the ravages of smallpox, and that was terrifying.
When people stopped seeing the impact of smallpox precisely because of increased vaccination rates, they'd get complacent.
When we look at history, vaccination rates have always waxed and waned. People become careless. And in the 19th century, when smallpox rates started to go down, sometimes there would be a lessening of vaccination, and then there'd be an outbreak, and then people would respond by getting vaccinated. When we had the last smallpox outbreak in the United States in the 1940s, 2 million New Yorkers lined up to get vaccinated, which tells you a lot about how people respond and with fear.
In the end, the smallpox vaccine was a huge success, both in the US and around the globe. In 1980, after a worldwide vaccination effort, the World Health Organization declared smallpox eradicated. That means it doesn't exist anywhere in the wild, and it's actually the only human disease we've ever fully eradicated. Smallpox needs a human host to survive. With so many people vaccinated, the disease couldn't find new hosts to infect, and it eventually died out. This is why vaccines are often mandated before kids can enter school. When enough people in a community are vaccinated, infectious diseases like smallpox or measles can't spread. The vaccinated people actually shield any unvaccinated people from ever encountering the disease. This is called herd immunity, and it protects people who can't get vaccinated, like pregnant people and newborns. So when parents decide not to vaccinate their children, their decision has a big impact on other families as well. The smallpox vaccine was a medical triumph, but in many ways it was really rudimentary. For years, inoculations were done arm to arm, with doctors swapping one person's cowpox scab and using it to vaccinate another person. Not to mention that most diseases don't have a less harmful cousin that can be easily given to make a person immune. However, as germ theory became understood in the late 1800s, scientists realized they could create other types of vaccines in the lab. In the next episode, we'll explore how more modern vaccines are made and why they include certain additives, like aluminum.